Welcome to my introduction to Python. This is Kim Kanofsky, and this is actually something that I would have presented originally over several weeks to my students. So it's just kind of an overview of the different lessons that I would put for Python. So programming languages are languages that can speak to your computer. We've used Scratch and Codable, Tinker and Code.org, Swift Playgrounds, and other platforms, and they've all been preparing us so we can learn how to communicate and how we can program our computer. Much like people around the world communicate in different languages, computers must understand the language in which you're communicating in order to interact with you. Unlike most people, though, computers are really specific with their language needs. Before they can understand what we're trying to say, they need to make sure that everything is spelled correctly. We haven't forgotten any punctuation. All the steps are in the correct order. If we don't have all that, the computer cannot figure out what to do. Much like using proper grammar and punctuation when we write, we use proper coding language when we code so it can be translated into a language the machine can understand. We type in specific information and use an interpreter, we'll find out more about that word in a minute, to put this information into a machine language that the computer can understand. When we practiced coding with other platforms, we were able to pick up blocks and move them around, and for the most part, those blocks told the computer what to do, and that had stuff already written on it. So it would tell it when to do things and if it should do things. Now we're just going to try and do all of that coding ourselves rather than picking up and moving blocks. Sometimes those blocks made it difficult. Sometimes it made it easy. But no matter what, when we messed up, we had to try again, over and over again until we got something correct. When we learn to code, we're not learning just so we can have an avatar dance around a screen, make a cat meow, make something flap, all those different things. We're learning really important critical thinking skills. We're learning how to work with others to solve problems, and especially perseverance. When things are difficult, we need to be able to try again. We need to problem solve. We need to seek assistance, discuss the problems with friends, seek out our teachers, and then try it over and over again until we can finally get it right. The language we're going to look at today is the Python language. And here's a fun fact. Python was not actually named after the snake. It was named after a British comedy group that my family really enjoys called Monty Python. The creator of Python liked the comedians and their show, The Monty Python's Flying Circus, and decided to name his programming language after them. Python's already installed on your device, so just look for that icon that's similar to this one, and we'll get going. Here's our vocabulary alert that I kind of led you to earlier. An interpreter is a program which translates your code into machine language and then executes or performs it line by line, and it's in the order in which you told it to do things. Now, Python uses an interpreter to take the information that we type in and turn it into a machine language the computer can understand so it can run the program. Much like a person who speaks a different language often needs an interpreter to translate or change the words that we're saying into a language that they can understand. Now, Python has an interactive and a script mode, and an interactive mode that's actually called the Python shell. This is where Python interpreter waits for you to enter a command, and then you can enter something, it executes or performs it, and then the command waits for your next command. It's commonly known, the Python interpreter is commonly known as the Python shell. It also has a script mode where Python interpreter runs a program from the source file. And finally, there's IDLE, which is short for Integrated Development Environment. It has a text editor with syntax highlighting, auto-completion, a smart indent, which is really cool because it knows when it needs to be indented for the computer to understand, and then it gives you more help along the way. It also has a debugger so that it'll help you try and locate some of your mistakes. And here's another fun fact. Many people believe that this environment, the IDLE environment, was named after Eric Idle, who's one of the members of the comedy group Monty Python, for whom Python language was named. So his last name is Idle, and a lot of people think that that's how it originated. Now, variables. Variables are something that we talk about in mathematics a lot. And we talk about them, though, in different things in life. Now, as we get older and as we go out into the world, there's so many different things that vary. Temperatures change, and people can color their hair, and shoe sizes can get bigger, and people like different types of food. So all of those are differences that vary or change. And we can often use a letter to show that it could be a lot of different choices. Like not everybody is the same height. So here, H is a variable to represent the height of an object or person, and it can change depending on who the person is or what the object is. And variables in Scratch, we used something like X when we were talking about moving right or left, and we used Y when we were talking about moving up and down, and that's very common in math. X and Y is usually used for the X and Y axis. X is usually right and left, Y is usually up and down. Also in Scratch, the variable could be used to allow for random selections or for the user to make choices from several options. So it's there because sometimes there needs to be a change or a choice, and it needs to just kind of hold that place for something that can kind of change over time. Variables in Python need to be defined, and they can be represented by any letter or word. They have to have quotation marks around them. You really shouldn't have pluses or minuses. And they are case sensitive, meaning if you put in one capital letter, you always have to use that same capital letter. And then there's just storage or placeholders for changing numbers or text. If you'd like to offer color options for like the color when you're drawing, and there's a certain program called Turtle that we'll talk about in a little bit, you can store that pen color by just putting it in quotation marks, something like this: pen color equals quote green, end quote. And so then it's telling the pen color, well, okay, you need to be green. Our common first program would be a Hello World program. So that's what we're going to do first. So open Python idle. When you open Python idle, it'll look something like this on the right there, and start by typing in the print command to tell the printer to print something. So after those 3 arrows, you can start typing. And whatever you want the computer to print, you need to put in parentheses and quotation marks. So please type in exactly what we have here. So after the 3 arrows, type the word print, beginning parenthesis, beginning quotation mark, hello world, exclamation point, end quotation mark, end parenthesis. Try it and type in the code and then press run. If it asks you to save the file first, save the file under the name Hello World. When you run the program, the computer will print Hello World on your screen, and with the same spelling, capitalization, punctuation, and everything else that you've entered. So if you misspelled it, or you didn't put in a capital, or you left out a space, it's going to print that as well. Now you finished your first program, so let's try another. The Hello My Name Is program. Let's add a section where you can enter your name and the computer will say hello to you. We define our variable name and tell the computer to ask the user for input. The /n tells the computer to return to the next line before allowing the user to type in his or her name. So just like I have written here, type that in next to your 3 arrows. Name equals input, and then with our parentheses and quotation marks, what is your name, question mark, \n, and then we want it to print. Hello world, this is, and then we put that comma and then name. And because we've defined that name is going to be whatever the user has put in, it will put in there whatever name the person types in. So for hello, my name is, we've defined our variable. We've told the computer to ask the user for his or her name. So now we can run the program. And when we run it, you can look in this box below and see that if I typed in Mrs. Konofsky, it's, what is your name? Mrs. Konofsky. Hello world, this is Mrs. Konofsky. And it shows exactly. Now, if I would have mistyped that in any way, shape, or form, it's exactly what it would have shown. The next thing is loops. A loop is continuous. If you follow a loop around and around, you won't stop unless something causes the loop to break apart. Loops in coding work the same way. Sometimes we need a computer to continue to do something until a specific thing happens or when something stops. So we can create a loop for something to happen again and again until or when that happens. What if we wanted to roll a die? A roll means I could get a 1, 2, 3, 4, 5, or 6 each time I roll. I want the computer to give me a random number greater than or equal to 1, but less than 7. So I can start by importing this random number generator. So import random. When I'm rolling a die, the next thing I need to type is to tell the computer what I need to ask the user. So I need to input, press enter to roll. And that tells the user they need to press the enter key to roll or pretend to roll, which really just means it's going to give me a random number somewhere between 1 and 7, but it excludes 7. So the dice has to be defined here. Dice is going to be a random number. And again, we were using this random number generator that's already kind of stored in Python. And the range has to be between 1 and 7. It includes 1, but it doesn't include that last number. So it's between 1 and 7, but not including that n number. Finally, I want the computer to print the number it just generated to show the user which number was rolled on the die. Now, obviously, it doesn't roll a die in there. It just uses whatever it's generated as its random number and puts that in and shows us that as our result. So rolling a die, the entire code would look like this. So let's try that. All right, for a while loop, if I want the user to be able to press enter so the die will roll again and again, so I can get more random numbers or roll the die over and over again, I need to have a loop while this is true, while you can still keep rolling, while you can still press the enter button. This is going to keep going. So here is our next one that we're going to try. We're going to import random while this is true. Notice the indentation next to input and dice, and then printing the actual answer to the dice. There's a lot of mathematical logical conditions that you can put into Python, or that Python understands, I guess I should say. So in equals, if you want that, you need to use 2 equal signs. Not equals, that's the exclamation and then an equal sign. Less than, it's just that simple arrow facing, like pointing to the left. Less than or equal to, arrow pointing left and an equal sign. Greater than is an arrow pointing to the right. And then greater than or equal to, arrow pointing right, and then an equal sign. The if, elif, and else statements are simple programs to show that one variable is greater than, less than, or equal to another variable. And we use the if, elif, and else statements when we're trying to declare a sentence that's true. For example, an if statement, if we want to compare two things, like if I know that John is 23 years old and Greg is 32 years old, I can say that J stands for John and G stands for Greg, and then I can compare the two. If G is greater than J, then I need to print this statement that Greg is older than John. Now I'm looking at my numbers and Greg is older than John, so it should print this. But what if I don't know that? Or what if that changes over time? What if my J and my G change over time? Well, then I need an elif statement. Or else, if John is greater than Greg, or J is a larger number than G, I need to print that John is older than Greg. And finally, what if they're the same age? What if with this program here, we find out that they're the same age? Well, then we need to have an else if they're equal. So J equals G. Then John is the same age as Greg. So now it's our turn to try that. All right, in Python, there's also something called Turtle. It's a drawing program. And you can refer to Turtle to make drawings. Really kind of cool. Again, you can just import it like this. And then you use variables like we did before. In this case, we could say T is equal to the pen that we're going to use to draw in Turtle. And that's so that we don't have to keep writing Turtle pen all over and over again. And we also have to define other things, like how fast is it going to move? What's the width of the pen? Is it going to be a really thick pen or thin pen? What's the beginning color? Stuff like that. When you're moving your Turtle, you can do a ton of different things, but some very basic ones would be to move forward, backward, right, and left with your Turtle. If you wanted to create a square with your Turtle, you could do something like this. Well, we import Turtle. And then we want our Turtle to move forward. Well, we need to pick how many pixels it's going to move forward. So in this case, 75 pixels. Then we need it to turn. If we're making a square, all of the corners are going to be 90 degrees. So when we're saying Turtle left, meaning we needed to turn to the left, we're telling it we needed to turn 90 degrees to the left. Because all four of the angles in a square need to turn 90 degrees. All four of those turtle lefts need to be 90. And because it's a square, all four of those pixels need to be 75, so that it's 75 pixels long. Functions can be created so you can use code in more than one program. To create a function, you first have to define the function. So you can define a function using this def. here. In this example, we needed to find the thickness of a narrow pen. So we want to be able to use different size pens.